in this video we will discuss about activity 2.10. Okay, so let us see what is given here. Divide the class into two groups. Okay, give 50 gram of iron fillings and 3 gram of sulfur powder in a china dish to both the groups. Alright, so what are the things that both the groups got? Both the groups got 50 gram of iron fillings, okay, means pieces of iron, small pieces of iron, and the other one and other substance is 3 gram of sulfur. So both the groups got it. Now group 1, mix and crush iron fillings and sulfur powder. Alright, they are mixed. Group 2, mix and crush iron fillings and sulfur powder. Heat the mixture strongly till red hot. Remove from flame and let the mixture cool. Okay, so both the groups have done some different things. The first group, they have just crushed both the substances and they just mixed it. Okay, but group 2, they are heating it. What is the difference there? Remember that due to this heating, some chemical reaction will take place there, and as a result iron and sulfur will undergo some chemical reaction, and what they will form? They will form iron sulfide. Iron sulfide, the formula is FeS, iron sulfide. This thing they will form. Which group? That is group 2. But with group 1, nothing such things will not happen, because they are not heating. They have just kept the thing as it is, right? So with group 1, the thing that we have, that is the mixture, but in group 2 that we have, that is a compound, because here in group 2 iron sulfide is formed, and this iron sulfide, in iron sulfide, iron is not retaining its property, sulfur is not retaining its property. They have become something else, and that is iron sulfide, and the color of iron sulfide is, it is blackish, it is blackish brown. Alright, so this is iron sulfide. Now let us see. So next one, group 1 and 2. Now what they got? So group 1 and 2, check the magnetism in the material obtained. Bring a magnet near the material and check if the material is attracted towards the magnet. Alright, so for group 1 and for group 2, a magnet is brought near. So if it is brought near, the iron fillings present in the mixture of group 1, those will be attracted by the magnet. But in group 2, they don't have iron now. What they have is iron sulfide. So certainly the iron present there will not be attracted, because iron is not retaining its property. They have become iron sulfide. Alright, next one. Compare the texture and color of the material obtained by the groups. Certainly, as I told you, iron sulfide, the color is blackish brown, so it has got a different color, but the group 1, they are retaining the color of iron and sulfur. Okay, next one, add carbon disulfide. Carbon disulfide is a solvent type material to one part of the material obtained. Stir well and filter. Okay, so what is added now? Carbon disulfide. Now when this carbon disulfide is added with iron sulfide, what will happen then? And when this carbon disulfide is added to the first group, to the mixture of first group, remember that these are some chemical changes will take place. I am telling you about it. Group 1 is having only mixture, right? Group 2 is having a compound, which is iron sulfide. So in that mixture, when carbon disulfide is added, then what will happen? This will dissolve the sulfur present in group 1, in the mixture of group 1. Sulfur, it gets dissolved in this solution, carbon disulfide. In this solvent, it gets dissolved. So once sulfur gets dissolved, we will get there a yellowish liquid after dissolving. Okay, but the iron will not dissolve. Iron will remain like it will settle, iron will settle down at the bottom of the vessel. So once you filter, then what will we get? Iron will be coming as residue for group 1. But in group 2 there is no such sulfur. Sulfur is not showing its property in group 2, in the substance of group 2, in the compound of group 2, because it is iron sulfide. Iron sulfide is having a different property. It is not same with sulfur or iron. So this iron sulfide, when this carbon disulfide is added, nothing, no changes takes place there. It will remain as it is. Okay, but in mixture in group 1 there will be change, because sulfur is showing its property and it gets dissolved in carbon disulfide. Okay, next one, add dilute sulfuric acid or dilute hydrochloric acid to the other part of gas obtained by group 1 is hydrogen. Okay, so what they have added now with group 1 and group 2, with both the things present with them, either you can use hydrochloric acid or you can use sulfuric acid, anyone. If you use anyone, then from group 1 hydrogen gas will come out, which is a colorless gas, odorless gas. Okay, hydrogen gas will come out, which is this one. Okay, hydrogen gas will come out, which is colorless, odorless, and it undergoes it is combustible, means it undergoes it catches fire. Okay, but with group 2 what will happen? Because with group 2 we have iron sulfide, that sulfur of iron sulfide, it will react with hydrogen that is present in sulfuric acid or hydrochloric acid that we have added, and it will form hydrogen sulfide gas, H2S. This gas is colorless, but it has a smell like rotten eggs. But when hydrogen is evolved, that means in group 1, then it is clear gas and it has no such odor. Right? So these are the changes that we will be observing with group 1 or group 2. Alright, so here certain things are listed, already we told about, we have discussed about it. Here the material, this one, the material obtained by group 1 is a mixture of the two substances. Alright, the substances given are the elements iron and sulfur. Okay, fine. The next one, the properties of the mixtures are the same as that of the constituents. Yes, because iron and sulfur, they retain their property in group 1. The material obtained by group 2 is a compound. Yes, it is a compound. And what compound is that? I told you it is iron sulfide. Alright, then on heating the two elements strongly, we get a compound which has totally different properties compared to the combining elements. Alright, this is iron sulfide. The composition of the composition of a compound is the same throughout. We can also observe, yes, it is correct, like when it is iron sulfide, certainly the composition will be same throughout. But if it is a mixture, in somewhere the amount of sulfur may be more, in somewhere the amount of iron may be more. In mixture the composition is not definite, it is not same always. Okay, so that's what is mentioned in this points, so you can go through it. So almost we have discussed all the topics from this chapter. So now we will proceed to the exercise. Okay, first of all I'll tell you that from this question number 10 and question number 11 will be your homework. Okay, you try to solve. In case if you cannot, I'll help you, then you let me know, I'll tell you. Fine. So number 1, simple questions. Which separation technique shall we use for this following things? The first one is sodium chloride from its solution in water. So what process is that? We can use evaporation. Okay, Ammonium chloride from the mixture containing sodium chloride and ammonium chloride. Ammonium chloride is a volatile one, so sublimation process we will use. Okay. Then next one, small pieces of metal in engine oil of a car. This is some simple filtration. If you filter the oil, these pieces of metals will come out. Next one, different pigments from an extract of flower petals. So flower petals, it is chromatography, color pigments. Butter from curd, it is centrifugation. Oil from water, that is by the process of separating funnel. Tea leaves from tea, simple filtration. Iron pins from stand, you can say by the process of magnetization. Means if you bring a magnet, it will attract the irons. So in this way, irons can be separated from sand. Next one, wheat grain from husk. So that is it is called winnowing. Such a process is there. We call it winnowing. It is not in your book, but you can note down the name, winnowing. Okay. Next one, fine mud particles suspended in water. So for that we can use sedimentation. We can allow them to settle for some time. So in that way we can separate. Next one, number 2. This one you can do only. Write the steps you would use for making tea. So you know how to make tea, right? And the other, what are the solvent, solute, solubility, insoluble, filtered, these things, these terms you are asked to mention. Anyways, simple word you write that when we make tea, that water and water will be the solvent, and the other things which are added, that is the solute, milk, sugar, then tea leaves, and then after making tea, what we do, we filter it, right? And when you filter it, the tea leaves remains as residue. Excuse me. So this tea leaves remains as residue. The rest thing becomes the filtrate, and it comes out from that this one, what to call, we say that is by after the filtration process. After filtration process, whatever thing is we get, that is the filtrate, and the residue, it remains in the the thing that we use for filtration. Okay. The next one, number 3. So here you can see that is a table is given, and in this table at different temperatures, see 283, 293, 313, 333, 353, in this temperature, these all are given in Kelvin scale. So at this temperature, the solubility of this compounds are written, like potassium nitrate 21 at 283 Kelvin, 32 at 293. So what are the meaning of this 21, 32? That means in 100 gram of water, 21, suppose I am talking about this one, okay, this one I am talking about potassium nitrate. Alright, at 283 Kelvin temperature, 21 gram of potassium is soluble in 100 gram of water. That is the meaning. Okay, then if the temperature is increased, now if the temperature is 293, then in 100 gram of water, 32 gram of potassium nitrate will be dissolved. That is the meaning of this table. Okay, now we will see that what are the questions given. Alright, first question, this one. What mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 gram of water at 313 Kelvin? This is 313 Kelvin. This is potassium nitrate. What is its solubility? It is 62. But this 62 is in 100 gram of water. But in question, you have 50 gram of water. In 100 gram, 62 gram of potassium nitrate is dissolved. So in 50 gram, how much will be that? It is just half of that. 150 is half, right? So half of 62 is how much? 31 gram. So your answer will be 31 gram potassium nitrate can be dissolved in 50 gram. Okay. Then number B. Pragya makes a saturated solution of potassium chloride in water at 353 Kelvin. Okay, and leaves the solution to cool at room temperature. What would she observe at the solution as the solution cools? Okay, 353, right? 353. What is she taking? Potassium chloride. All right. So potassium chloride in 353 is 54 gram, right? That means in 100 gram of water, how much potassium chloride can be dissolved? It is 54 gram. So if it is 54, now if the temperature is, if it is cooled down, it is cooled, right? So when it is cooled down, the temperature is reduced. You see the number, that 54 will also reduce, isn't it? This 54, now it will, when the temperature is reduced, it will become 46, 40, 35, 35, in that way. So if the amount decreases, that means what? It has 54 gram, but when the temperature is reduced, it cannot dissolve 54 gram. Now it can dissolve either 46 or 40 or 35 or maybe any value which is less than 54. So some amount of potassium chloride will remain in that solution undissolved. When the temperature was 353, 54 gram can dissolve, but when it is cooled down, it is written that it is cooled down. So that means now it will not be able to dissolve 54 grams. So how much will it dissolve? Less than 54. So that means some amount of, you just have to write that means some amount of potassium chloride will be undissolved, okay, as it is cooled down. Next one, number C. For the solubility of each salt at 293 Kelvin, which salt has the highest solubility? Okay, the temperature is 293. In 293, you see this column. Which one is having highest solubility? Highest solubility is of this one, right? 37 is the highest number here. So it is ammonium chloride. So answer will be ammonium chloride. Next one, that is, what is the effect of change of temperature on the solubility of a salt? So you just write that as the temperature increases, the solubility increases, isn't it? See, just only one row also, if you see, it will be clear. When the temperature is 283, solubility is 21. Temperature 293, solubility 32. So the solubility is gradually increasing with increase in temperature. So what you will write is, with increase in temperature, solubility of a salt increases. Alright. Then next one, number 4. Explain the following giving examples. Saturated solution. We already discussed about these things. What is saturated solution? You know this. You can write down. Pure substance, colloid, suspension. We know all these things. We have discussed several times. So this one you try. If you find any difficulty, tell me. I will give you the answer. Okay. Number 5. These things already we discussed also. See, classify each of the following as a homogeneous and heterogeneous mixture. Okay, soda water. Soda water is a homogeneous mixture. Wood, it is heterogeneous. Air, homogeneous. Soil, heterogeneous. Vinegar, homogeneous. Filtered tea, homogeneous. Now, next one. How would you confirm that a colorless liquid liquid given to you is pure water? Okay, now suppose pure water means, we know that for pure water the boiling point is 100 degrees Celsius. So in case if you are boiling the water and the water is not undergoing vaporization at 100 degrees Celsius, that means this is not pure water. If the temperature is little less or more, you have to understand that this water is not pure water. Next one, number 7. Which of the following materials fall in the category of a pure substance? So pure substance, ice is a pure substance, iron pure substance. Okay, I'll just take the pure substances. Ice is pure substance, milk is not. Iron pure substance, hydrochloric acid pure substance, calcium oxide pure, mercury pure, wood brick no, air is okay, air we can take impure because some dust particles may be there. Okay, brick and wood is not pure substance. Then next one, number 8. Number 8. Identify the solution among the following mixture. Soil, it is not a solution. Sea water, okay, solution. Air, solution. Coal, no. Soda water, solution. Which of the following will show Tyndall effect? Salt solution, no, because it is a true solution. True solution does not show Tyndall effect. So milk will show Tyndall effect. Copper sulfate is a solution, is a true solution, it will not show. Milk is a colloidal solution, so it will show Tyndall effect. Starch solution is also a colloidal solution, so it will show Tyndall effect. Okay. And then question number 10 and 11, I told you that that will be your homework. You try to find it out. If you find any difficulty, let me know. And here, from here, question number 4. Okay, so this chapter is over. Then we will proceed to the next chapter, that is chapter